So I just ended doing this one, so I'll repeat it again. If we have this function and we want to write it in factored form, which is this, we start with the zeros, I write them out, and then I have to make sure that my leading coefficient is a 13. So this doesn't make a 13, x times x. So then at the end, I'll multiply by 13, so that'll fix everything to make it this big mess. So these are the two zeros, and then to make sure I have a 13 out front, I write 13 out front. Let's look at our other example. Here I need a 7 out front, right? But they tell me the zeros. So if they tell me the zeros, they're making it easy for me. I'm just going to write them out. Negative 1 being a 0 is x plus 1. Positive 1 being a 0 is x minus 1, because when I put 1 in there it becomes a 0, and 3 being a 0 is x minus 3. Now if I multiply this all out, I'll have just a 1 in front of the x, right? X times x times x, but I need a 7, so I put the 7 right there, and there we go. This is the factored form of this, but they are just telling me the zeros, making it much easier on me. Now if they don't tell me all of the zeros, like in this example, look at this function, and they give me one of the zeros. So they say x equals 5 is a 0. If that's a 0, x minus 5 is a factor, right? I know one factor, but how many zeros are there in a cubic function? 3. So I want to find the other zeros. So let's divide this one out, either long division with this or synthetic division with the 0. So if I do synthetic division, I'll go like this, and then put my coefficients up there, 3 minus 11 minus 35 plus 75, and I drop the 3, right? 15 minus 11 is 4, 20, negative 15. Now what should I expect to get here? 5 times negative 15 is negative 75. I should expect to get a 0 here because x equals 5 is a 0, meaning 3x squared plus 4x minus 15 is the quotient after dividing out x minus 5. You have to get a 0 there because it says that x equals 5 is a 0. Okay? Remainder has to be 0, so this comes out to be an even factor. Alright, so this is what I know so far. I know that my function was like this, but now I divided the x equals 5 out as a factor of x minus 5, so now I have this. Now I have a degree 2, and how we solve degree 2s is we can find both of these zeros either by factoring here, or we can use the quadratic formula, right? That'll give both zeros. If I have both zeros, then I'm able to write both factors, right? Both factors. Alright, so let's move this down here. I'm going to use the quadratic formula to find both zeros. So looking back up here, I have an a as 3, I have a b as 4, and I have a c of negative 15. Now you can do this yourself. I just quickly did it here, and it works out that my other two zeros, these are my zeros now, are 5/3 and negative 3. So zeros are 5/3, negative 3, and positive 5. Now I'll write it in factored form. Negative 3 is a 0, 5/3 is a 0, and 5 is a 0. These are my zeros. And what was the leading coefficient of the problem starting out? It was a 3. So I need that 3 written right out front. So that's my answer in complete factored form with the 3 out front. If I didn't put the 3 out front, then I have a problem. Alright, look at my second one down here though. This is the same answer. But where is the 3? It's multiplied in here. Right there it is. See? What's 3 times x minus 5/3? Well, it's 3x. 3 times 5/3, the 3's cancel, minus 5. Right? So I've taken that leading coefficient and multiplied it in there. This is also correct. It also shows all three zeros, right? Negative 3. 5/3 is the 0. If you put 5/3 in there, you get 0. And x equals 5. So either way is correct with that coefficient in here. Usually they do that to get rid of these fractions in here. They multiply that one in the one with the fraction only. I don't multiply it in this one because if I multiply in this one, it would be 3x plus 9. That 3 can be factored out. Multiplied in the one with the fraction only because this is all multiplied together.